Welcome my dear students to my math channel. This is Mr. Mahmoud explaining Algebra 2, Chapter 6, Lesson number 1, Graphing Exponential Function. The parent function for the exponential function is f of x equal b to the power of x, where b is greater than 1. It's continuous and one-to-one increasing function as b is greater than 1. The domain will be from negative infinity to positive infinity, or we can say all real numbers. The range is from 0 opened up to infinity. The asymptote is the x-axis, or we can say the line y equals 0. It intersects the y-axis exactly at the point 0 and 1, because naturally if you substitute with x as 0, it will be b to the power of 0, and any number to the power of 0 will give you 1. No symmetry and no extreme. Example 1. How can we graph exponential growth function? Graph y equals 2 to the power of x, state the domain and range. We will follow the table method. So let's take x values from negative 2 to 2. Then we substitute in the substitute for x, means 2 to the power of negative 2, then 2 to the power of negative 1, 2 to the power of 0, 2 to the power 1, 2 to the power 2, and so on, and you will have these results. Now we will plot these points on the coordinate system. 2 goes up to 4, 1 up to 2, and so on. So I have 0 from 2 up to 4, and from 1 up to 2, from 0 up to 1, negative 1 to half, and so on, getting closer to the x-axis, but we don't touch the x-axis. The domain in this case is all real numbers, extending from negative infinity to positive infinity. The range is all positive real numbers. You can notice that the graph will not be under the x-axis, it will not touch the x-axis, so all results are positive numbers. Or you can say the range goes from 0 opened up to infinity. Now, which is the graph of y equals 3 to the power of x? A, B, C, or D? Yes, it should be C, because this one represents the exponential growth. So 3 to the power of x will be represented by this one. Another reason, if you substitute here with 0, 3 to the power of 0 will give you 1, so this is 0 and 1. If you substitute x as 1, 3 to the power of 1 will give you 3, so 3 up to 1, so this is the actual graph. Now, transformations of exponential function. F of x equal a, b to the power of x minus h plus k. H represents horizontal translation, the number added or subtracted from x in the power. H units right if h is positive, absolute h units left if h is negative. But you need to pay attention for this negative sign. K vertical translation, k units up if k is positive, absolute k units down if k is negative. Now, what does A do? What does it do, A? A will give you orientation and shape. If A is smaller than 0, the graph is reflected in the x-axis, means if this A is negative, it will cause reflection along the x-axis. The absolute value of A, if it's greater than 1, the graph is stretched vertically, means vertical stretch. If the absolute value of A is smaller than 1, means between 0 and 1, the graph is compressed vertically. Now, graph the function y equals 3 to the power of x minus 2, state the domain and range. It's clear that 3 to the power of x, all of it minus 2, means this minus 2 is k value. And we have mentioned that k makes vertical shift, up if positive, down if negative. So this negative 2 will cause vertical shift down 2 units. Now let's do the table and let's see how can we graph. The equation represents a translation of the graph y equals 3 to the power of x down 2 units. Now take x from negative 3 to 3, substitute x using your calculator, you will have these results. Now let's try to graph 3 up to 25, 2 up to 7, 1 and 1, 0 and negative 1, and so on. The graph will take this shape. It's clear that it's similar to the graph of the exponential growth, but it goes down 2 units. So the domain in this case is from negative infinity to positive infinity, or you can say all real numbers. The range, since the graph goes down negative 2 units, so we start from negative 2, goes down 2 units, so we start from negative 2 up to infinity. The range from negative 2 opened up to infinity. Or you can say y such that y is greater than negative 2, or y goes from negative 2 to positive infinity. Graph the function y equals 2 to the power of x minus 1, state the domain and range. We have here minus 1 is with x in the power. So this is a value of h. And h causes horizontal shift. To the right if negative, to the left if positive. Means with inverse sign. So I can say that since it's negative 1, x minus 1 means 1 is in negative. So it will go to the right 1 unit. Let me show you how. The equation represents a translation of the graph y equals 2 to the power of x right 1 unit. Also take x from negative 3 to 3, substitute x for these values, you will have these results. Means 3 up to 4, from 2 up to 2, 1 and 1, 0 and half, negative 1 and quarter, and so on. And the graph will take this shape. So in this case, the domain also from negative infinity to positive infinity. You can say all real numbers. The range also goes from 0 up to infinity. No change in the range because we have horizontal shift, not vertical. Vertical shift will cause change in the start of the range. But since it's horizontal, stays the same from 0 up to infinity. Now graph the function y equals 2 to the power of x minus 4. 2 to the power of x minus 4 is the same as 2 to the power of x, but with 4 units down. The whole function minus 4 means 4 units down. So what to choose, A, B, C, or D? Yes, the right choice is C. Graph the function y equals 4 to the power of x minus 2 plus 3 is the same as 4 to the power of x, but we have 2 units to the right and 3 units up. 2 units to the right, 3 units up. So what to choose? A, B, C, or D? Yes, the actual choice should be A. Or you can, to know the actual answer, you can pick a number and try to guess. For example, let's take the number 2. If you substitute x as 2, this will be 2 minus 2, 0. 4 to the power of 0 will give you 1. 1 plus 3 is 4. So if you substitute x as 2, the answer should be 4. And it's clear that 2 and 4 belongs to the graph of choice A. In 2006, there were 1,020,000,000 people worldwide using the internet. At that time, the number of users was growing by 19.5% annually. Draw a graph showing how the number of users would grow from 2006 to 2016 if that rate continued. Means we have exponential growth. So first, let's write an equation using the start A as 1.020 in billions, and the rate, we should divide this number by 100 to transform from a percent into a decimal. So the rate is 0.195. Now it's y equals, this is the start A, we put the A here, 1.020, and we put the r here plus 1 because it's growth. So this value of r, we put it plus 1, means 1.195 to the power of t, which is the number of years. Now we have our function, we can easily graph. Then we graph the equation. Our start is 206, and we move on to 2006, 2007, 2008, and so on till we finish till 2016. Now, in 2006, there were about 2 billion people worldwide using cellular phones. At that time, the number of users was growing by 11% annually, which graph shows how the number of users would grow from 2006 to 2014 if that rate continued. So let me show you how you can do this. So at first, the value of A will be 2 billion people, and the rate in this case will be 11 divided by 100 is 0.11. So it's y equals A times 1 plus r to the power of t. So y equals A, which is 2, multiplied by 1 plus r, which is 1.11 to the power of t. And you can take this t, the start is 2006, means this is our 0. So take this t on the calculator from 0 to 214 minus 206 will be 8. So from 0 to 8, you substitute the t, and you will find the graph will be what? Yes, it should be D. Now, the exponential decay function. The parent function also is f of x equal b to the power of x, but in this case b is from 0 to 1, means b is a fraction like half, third, or a decimal like 0.1, 0.2, 0.9, 0.15. The value should be between 0 and 1. The type of the graph is continuous and 1 to 1 and decreasing as you can see. The domain is from negative infinity to positive infinity, or you can say all real numbers. The range also from 0 up to infinity, or you can say y, such that y greater than 0. The asymptote also is the x-axis, the line that we don't touch. The intercept, we cut the y exactly at 0 and 1. And it's clear that if you take the graph from left to right, it decreases. Now, graph the function y equals 1 over 5 to the power of x. State the domain and range. Look at 1 over 5. This is the b, the value of b. It's clear that it's smaller than 1 and greater than 0, means it will be in exponential decay. So now let's do the table. Take x values from negative 3 to 2 or from negative 3 to 3 is up to you. So get the y values using your calculator. 125, 25, root 5, 1, 1 over 5, and so on. Take the values to graph. It will give you this one. You can notice from negative 1 really up to 5, from 0 up to 1, getting closer to the x-axis, but we don't touch. Now the domain, as we mentioned before, from negative infinity to positive infinity, and the range goes from 0 up to infinity. The same transformations, if a number is added or subtracted from x, causes a horizontal shift with an inverse sign, means negative 1 will make it to the right 1 unit. If the number is added for the whole function, it makes a vertical shift up or down with the same sign. Positive means 2 units up, and negative 4 will cause, the negative will cause reflection, and the 4 itself will cause a vertical stretch. Also state domain and range. The equation represents a transformation of the graph of y equals half to the power of x, means this is the parent function for this one. Let's examine each parameter. There is a negative sign in front of the function. The graph is reflected in the x-axis. A equals 4, the graph is stretched vertically. H equals 1, the graph is translated 1 unit to the right because it has negative in front of it, so 1 unit to the right. K equals 2, the graph is translated or shifted 2 units up. Now you can use your calculator to graph. It's clear that it will be this shape. The domain in this case from negative infinity to positive infinity, and the range is from is not really from 2 to positive infinity as mentioned here. It should be from negative infinity up to 2, because here 2 is our asymptote that we will not touch, and the graph is extended all the way down to the negative y-axis. So we can say from negative infinity up to 2 open. Now, graph the function y equals half to the power of x. Half to the power of x, it's exponential decay. So it takes this shape or this shape, A or C. So we cancel the B and D. So what will you choose? Yes, it should be A. Now graph the function y equals negative 6 third to the power of x minus 2 minus 3. It's clear that we have h equals 2. H equals 2 means we have negative 2 means to the right 2 units. K is negative 3 means 3 units down. This is 2 units to the right. We have negative here means reflection. So A is negative means reflection along the x-axis. 6 will represent vertical stretch. So what to choose? Yes, it should be A, or simply you can take a number and substitute with, and this number will tell you everything. For example, if you take x as 3, take x as 3. So y will be negative 6 times third to the power of 3 minus 2, then minus 3. So y equals negative 6 multiplied by third power 3 minus 2 means 1, so minus 3. Negative 6 times third will give you negative 2 minus 3, this will be negative 5. So if x equals 3, you need to go down to negative 5. And really from 3 to negative 5 is here. So the right choice is A. By this, my dear students, we come to the end of our lesson for today. Till we meet again, goodbye.